What's up, guys? You're watching Death's Apprentice. I'm Ronnie, and today I'm going to be talking with you about the world's first attempt at Chidori. So, if you're unfamiliar with the concept of Chidori, the Chidori or Raikiri is a technique from the show Naruto, a very popular Japanese anime. The characters in the show are essentially ninja wizards in the sense that they possess and use various magical abilities to fight one another. In the show, a ninja named Kakashi creates a technique called the Chidori, an ability that allows him to create lightning within the palm of his hand. He uses this technique to pierce pretty much any object that stands in his path, whether it be a person's heart or an actual bolt of lightning. Now, in the real world, lightning is a very tricky thing to create. I don't have chakra or a Sharingan, so I just can't make it appear in my bare hand, but with a little bit of engineering and a decent understanding of electronics, I'm pretty sure anyone can overcome that challenge. So, about a year ago, I decided to try and create the Chidori myself. My first attempt was rather meager, but I quickly learned that holding lightning in your hand is possible. That is to say, you can manipulate and create plasma in the palm of your hand as long as you have sufficient protection. Now, what can protect you from lightning, you may ask? And well, that's pretty simple. An insulator. Now, depending on the voltage applied, you can use various kinds of insulators, whether it be a plastic or a rubber. However, when designing something for your hand, you want to still maintain mobility, so silicone or rubber is obviously the best choice. Now, there are plenty of insulating gloves designed for high voltage applications, but they tend to be fairly expensive. I elected to go for the cheaper route when first testing, but boy was I mistaken. Now, the first test I engaged in was rather dangerous. I strung together 5 or 6 high voltage DC transformers in series. Now, I want to say before I go any further that while these transformers are compact, they frequently fail. If you try to stretch out the arc beyond the limits of the voltage, you will easily damage the device. Not to mention they are incredibly loud and can only be used for a period no longer than 1 minute, which is not ideal for research purposes. So, when using these 6 transformers in series, they create an arc about 6 inches long, which should be around 100,000 volts. Now, I'm not sure why I thought this was a good idea, but I took the leads of the transformer array and I stuck them on a regular nylon work glove. You know, the kind a mechanic would use. I then placed my hand in the glove and handed the power switch to my sister, and as you can guess, this did not go well. The arc shot straight through the glove and went through my hand, and now I was never in any real danger of dying, but I probably could have lost my hand. Thankfully, I just ripped the entire device while my sister powered everything down. So, with a fresh burn mark on the entry and exit points of the arc, I decided to upgrade my gloves. Now, while I don't have footage of this next test, I can assure it went a lot better. I purchased a pair of Class 3 lineman gloves for about $40 on eBay. And if you've been in the market for these gloves, you know that's a very good deal, as these gloves tend to be around $300 or so. These gloves are rated at 27,500 volts AC. Now, typically the AC voltage rating is always going to be lower than the DC rating, most likely due to things like capacitive coupling, but I'm not an electronics engineer, so take everything I say with a grain of salt. So this time I used 2 transformers in series. I placed the ground in the palm of the glove and the positive on the index finger. I then put my hand inside the glove and turned on the power, and it worked great. The arc stayed within the glove and didn't harm me, and while a charge did build up around me, it didn't cause any electrostatic discharges. But now the problem became a matter of aesthetics and mobility. For one, the gloves are huge, like really big, and I don't like that. I wanted to look like Sasuke Uchiha, not Doomfist from Overwatch. Not only that, but the gloves were very hard to move, and I just did not enjoy the overall experience I was having. So I scrapped the project for about 6 or so months, focusing on other things like a flame sword and a railgun project I was working on at the time. Now, through pure chance, I came across a video on YouTube showing how if you wore a metal glove or a chainmail glove, you could touch lightning with no problems. The glove, of course, being electrically grounded. The man in the video was interacting with a small Tesla coil arcing the device, and small Tesla coils aren't known for putting out much in the way of current, and this would become a lot more important later on. So I revisited the Chidori project and found success. Not only was the glove a lot smaller than the insulated glove, but it was also more mobile. However, I began running into another problem. The transformers I was using began to break, as the act of me moving my hands caused the gap to exceed the distance the arc could jump. So I switched to a different transformer type. Behold the legendary flyback transformer. So if you've been on YouTube for a while and you're a high voltage enthusiast such as myself, then you know that flybacks are very popular and easy to obtain. whether you break an old CRT TV to find one, or just go on Amazon and buy a kit with a ZVS driver included. Flybacks are everywhere and are quite useful. So I made a new setup this time, incorporating design elements from projects past. I cut the fingertips from the insulating gloves and placed them on the grounded chainmail glove. I then 3D printed a holder for a graphite electrode that would serve as a breakout point for the arc. So the insulating glove would serve as a resistor, not allowing the arc to go to ground, and the arc would be forced to jump an air gap to get to ground. And that's how it worked. The arc jumped through the air and onto the grounded glove. However, the arc would jump the shortest distance possible, going right beneath the fingertip. This could be alleviated by closing my fist and placing the electrode in direct contact with the palm of the chainmail glove, and then turning on the power, because as I would open my hand, a plasma channel would be created and would serve as a low resistance path. But this would only last for so long, as opening the glove further would exceed the arc's capability of jumping the gap from my fingertip to my palm. So eventually the arc would create a new channel, jumping from the electrode to my fingertip, or the bottom of my fingertip. Not only was this annoying, but it ended up burning the gloves, as the arc was very hot, maybe around 4,000 degrees or so. And so the silicone would begin melting, and even the chainmail glove. Eventually the fingertips became unusable as they degraded too much. Well, now we are on the 5th attempt at getting this thing to work, and you're probably thinking to yourself, this guy must be an idiot and the premise is impossible, but I promise it gets better soon. So I switched the design entirely. I added 3 more transformers and then wired the positive outputs to a 3D printed housing that would connect the wires to their own graphite electrode and keep them separated from one another. That way I would have 3 individual arcs instead of 1. I then connected all the grounds of the transformers to the chainmail glove and tested the device. And so it worked, but the arcs were still too hot. Within seconds, the metal glove would start turning red, heating up to probably around 500 degrees. Throughout all these experiments, I had been wearing another glove underneath the chainmail glove to insulate me from the circuit, and the glove began to burn, causing me to get burned and shocked. Not only that, but the arcs were simply not long enough for my taste. To prevent me from getting burned again, I added a 10 ohm resistor on the primary side of the transformers. This led to the arcs looking very sickly and even smaller, so I cast the idea aside, and for some reason focused on making the arcs longer, as I figured I could just get a glove that was much better at insulating against the heat than the cotton one I wore before. I'm a welder by trade, so I know that there are certain gases that are more conductive than regular air, like argon and helium. And because of some tests I'd done in the past, I knew that if you injected metal powders into an argon atmosphere, it would become even more conductive, and you could generate not just longer arcs, but arcs with various colors. So I 3D printed a new housing for the high voltage wires that allowed a hose to be hooked in and allow argon gas as well as copper powder to be fed into my hand. I then used a regular mechanic's glove underneath the chainmail glove to insulate my hand from the heat, and this device completely met my expectations. With one problem. The 3D printed device now began to burn, as the introduction of the conductive gas allowed for the transformers to branch to each other and burn a pathway through the plastic to ground. This, however, was not the end of the world. I simply changed the infill density from 40% to 100%. This eliminated the air gaps and created a solid structure capable of stopping most charges from leaking through. And here's the final result. I hope you enjoyed what you saw. This device is not 100% ready, as PLA just can't cope with the intense environment created by the apparatus. However, I suspect if I use a ceramic, things will be much better. As always, thanks for watching. Feel free to drop me a like, subscribe, and I'll catch you in the next one.